Everybody, my name is Klingenmeier. I'm a sound guy from Colorado. Actually, currently I'm in Armenia in self-isolation, probably like you, so I hope you're safe and healthy wherever you are. I also would like to thank you for being here, and thank you Umanesimo Artificiale for having me. Today I'm going to be building a ambient generative track in Kyma. So a little bit different than this series so far, but hopefully it will still be interesting, fun. So in case you're not familiar or curious, Kyma 7 is a sound design language and environment. You can graphically code things with sounds like these, just drag and drop them and connect them together. You can get inside the sounds anywhere there's hot values like this with a red exclamation point and wording. That means it can be changed in real time on the fly. This is the real-time event language with the in-Kyma Cappy Talk, which we'll see a little bit of. And yeah, so what I'm going to be doing is pretty basic, straightforward. I think even if you're not familiar with Kyma or this sort of thing in general, you should still be able to follow along. So I'm thinking to do something with trumpet that I recorded, so maybe some granular trumpet orchestra. So I'm going to use a prototype called Sample Cloud, and just kind of as it comes, it sounds like this. You notice all these faders on here, the names are in red here, so they can be changed on the fly in real time. That just gives you a kind of a generic look at the insight of the sound. Let's go in here and get something of my own. That was it, actually, trumpets. Cool. And just to show you what I'm working with here. Trumpet with a bit of reverb. Quite basic. And I'm thinking to basically granulate this, but with long grains, so not the typical or sort of expected short grain that would typically associate with granular synthesis, and then get a lot of these trumpets on top of each other and spread out to create a lush texture. For my grain envelope, right now I've got this Gaussian shape, which is really nice and smooth, so I'll actually roll with that for now. The amplitude of the grain cloud is controlled in real time from this amp value. I'm okay with that as well, so I'll leave that. Frequency default means it's going to play back at the rate at which it was recorded. If I put in scale or a hot value there, I can change the playback in real time, which I like the idea of being able to do that. Frequency jitter is random deviation around that rate of playback. So this can be, depending on how it's used, subtle or not so subtle, sound microtonal or even very out of tune. In any case, typically I find that a little bit is a good thing, and so I'm going to put a little bit of randomness. So 1 second, that's the 1S, normal is going to grab a random number between -1 and 1 from a normal distribution, which centers around 0, or means numbers closer to 0 are more likely, which in this case would mean minimal frequency jitter, which is what I want. going to take the absolute value, because negative, I don't believe negative there will do anything for us. And then I'm going to scale it so that the largest value can be 0.01, which will still be audible, but keep it subtle. Time index is a pointer into the sample. So -1, here this range of this is -1 to 1. -1 will be the very beginning of the sample. 0 would be the dead center, and 1 would be the end, and then all the other values accordingly. So that means we can hang on a specific time, which can be interesting, but I'm going to randomly index the sample as well, this time from a uniform distribution, which we get to from writing random there. And then I want to linearly interpolate from the previous value to the new value, which is what smooth for is going to do. So every 10 seconds, I'm going to take a random number between -1 and 1, which is cool because that's what the time index is expecting, and then slowly, over the course of 7 seconds, get to that value. So we're basically going to just keep randomly scrubbing this file. Time index jitter, random deviation around that time index point. When this is 1, it can grab any bit of the sample at any time, which could be cool as well. I'm just going to grab random number here. Smooth just does this same smooth for, only assumes 1 second. This up here takes the additional argument that you can put in however much time you want. Density is how dense of a cloud, or how many grains might start up at any one time. Higher numbers, more dense. I'll do a bit of randomness here as well, and I'm just picking random times to increase variability, really. So every 11 seconds, take a random number, make it the absolute value so it's in the range of 0 to 1, and then smoothly go to it over the course of 11 seconds. So we're just going to keep gradually changing the density of the cloud. Grain duration is the length of the grain, critical parameter for the overall timbre of the sound. As I mentioned, I wanted to create a lush sound that's not immediately dense and having that short grain sound that may be familiar with. So I'll go 11 seconds, random absolute value, smooth for, let's just do 10 seconds. But this is looking for a value, and right now this is just giving us a number, or it's looking for a time, I mean. So I need to put it in seconds, or I'm going to put it in seconds. And then this would create a value up to 1 second grain duration, but I'm going to scale it so that I can have a grain duration up to 5 seconds, which is actually going to make a really long grain, and then we can have a lot of them. As we see down here, max grain's 28, and then I'm going to create even more, so we're going to end up with a really lush trumpet, granulated trumpet sound here. Grain duration jitter, this random deviation around that grain duration can be cool too. I'll just stick with this normalness, but not too much jitter. So remember, these numbers are closer to 0, which would be no jitter, which would mean that it's basically the number that's coming from here, which itself is changing. All right, pan. 0.5 means each new grain will come from the center. 0 is hard left, hard right is 1. So 0.5 is the middle. But I'm going to increase this to make it so that any grain at any time can come from anywhere in the stereophonic field by making the pan jitter 1, max grain 28, seed is a starting point for the random number generator. We'll roll with that, it's fine. And then in order to be able to hear some of these frequency scalings and changes, I need to change interpolation to linear. And let's check this out. Okay, so scale is at 1. It's playing back at the rate it was recorded. If I go to 0.5, it will go down an octave and be half the speed. So it's like going from 30 inches per second on the tape machine down to 15. You can also go even slower, say. So now we're down 2 octaves. Here's 3 octaves. I can read through it backwards with negative scaling values. Typically, I'm not a big fan of reverse, but I think in this context it actually works. Cool. And then, of course, we can continuously change it too. Don't have to just move by octaves. So depending on the tuning system, your ratios might come up with different ratios, or could be cool to experiment with different ratios, but I like to move in thirds and sixths, and 1 ratio for a minor third is 6/5, which comes out to 1.2. And then I could do octaves of that. So let's firstly create more of these. So now that I've got this cloud, I'm going to go ahead and replicate it, copy it a bunch. So I can take it and just drag. Here's what I was talking about before. Just drag and drop it on there. And now it's feeding into this replicator, which is copying it. Right now, it's copying 4 times. Let's go ahead and hear that for now. Left and right, amp low, that's the overall volume after the replication. And then basically everything that's red here is going to get the suffix _1 and then be incremented. So let's check it out. Okay. So now you see we have amp 1, 2, 3, 4 and scale 1, 2, 3, 4. If we go back and look in here, we see that those 2 are in red, so it makes perfect sense. Now let's hear this. It's some different octaves on top of each other, so I'll take it down. And then let's check out that third, minor third. Of course, I could get the amplitude randomly changing as well, but sometimes it's nice to be able to just change it in real time. Starting to sound interesting. It's not quite enough. Let's just double it. Get 8 of these, so now you'll see we've got 8 amps, individually controllable, 8 scalings. So again, let's check this out. One is fine, 2. with a minor third. Minor 6 is a ratio, once it's divided out, 1.587. I can do octaves of these. Okay. It's getting there. But I'm going to go ahead and make it a dozen softly wailing granular trumpets. Saved my preset up here, but I missed out. That's all right. Do it again. 0.125. Point 2. I can change the range. Right now this scale value is going from -2 to 2 with a grid of 0, which means it's continuous. I could set a grid value for the smallest increments I want to move, but I want to keep it continuous. So I'll leave that at 0. But I'll go ahead and change this from -4 to 4. So we can go up even higher maybe. Yeah, and so now it's interesting, enough going on, slowly evolving, coming to life. I can make this my new default. Let's just see what would happen if we went 2 dozen wailing, softly wailing granular trumpets. And I gotta get more ratios here. A perfect fifth. Look it up to be sure. Three over 2, yeah. So comes in at 1.5, then I can go changes to 3. Yeah. So that's pretty cool. So you can see how it's slowly changing, all from this basic sound. One thing I do want to do is change the seed so that each replication has its own seed. the random number generator so that they're not just duplicates of one another. Now we should hear this be a little bit more interesting. Yeah, and I could continue to check out higher octaves and other ratios and basically just keep putzing around and fiddling around with it, but I'm liking the way this sounds, so yeah, probably just gonna get this going. But that's the basic use of the sound, and obviously this is about as simple of a Kyma sound as we can get. I would be curious, maybe we can see, or rather hear, with a different grain envelope. This is also smooth, what this does for our sound. Another one, hamming envelope. So these are all smooth, create the really not so abrasive grains. But you can hear there is a bit of a timbre difference. Okay, I think I'm going to go back to the Han. Use this shape for the grain envelope. See what happens with some higher octaves. Too much. And bring that particular cloud down a bit. Yeah, so there it is, a rather simple Kyma sound, simple generative system, but it will keep evolving and creating interesting little snippets of trumpets and interesting harmonies. So there it is. I hope that was in some way stimulating and useful for you, maybe sparked an idea. And again, thanks for tuning in, and again, thanks to Umanesimo Artificiale for having me, and I look forward to the rest of the series and hearing what everybody else creates. And again, my name is Will Klingenmeier. In case you're curious about Kyma, I have more on my YouTube channel here as well. If you're curious about my sound journey, it's a good place to be. And here's my other handles. So find me, reach out with questions, comments, and continue to stay safe, everybody. And I appreciate you tuning in. Take care.